Hello, this video continues our lesson on how to use the short-run New Keynesian model to obtain numerical results. So let's look at an example that we've done here. This will be actually a familiar example here. Over here on the left-hand column here, this is the baseline assumption for shocks. These are all the shocks. Productivity-based shocks, that's the aggregate, short-run aggregate supply curve. Here's the expected inflation. Here's the target inflation rate. Here is the autonomous shock to the IS curve, which is aggregate demand. And here is discretionary monetary policy along the RT curve. And we can see that expectations are aligned with the target. So here we are, 2.4, 2.4. So there's no expectations gap, and there's no other shocks. Now it turns out that in our alternative scenarios, we're going to be keeping expectations aligned with the target. So this is the same as this, and this is the same as that. So there's no expectations gap in any of our alternative scenarios. Our first alternative scenario is simply an increase in aggregate demand, and there's going to be no monetary accommodation. So we're going to have 1.5% increase in aggregate demand relative to, or as a percent of potential output. Okay, and that's going to be our rightward shift in the IS curve. And then here in alternative 2, we're going to have that same increase in aggregate demand, but now we're going to suppose that the central bank accommodates that. And how does it accommodate that? By lowering interest rates on a discretionary basis. You can see here, if we move down, we have calculated all of the elements in the numerator, and actually this is a pretty easy example because we have no expectations gap, so that element is 0. We have no supply shock, so that element is 0. We have only an aggregate demand shock, and you remember that we have to adjust this first by this coefficient, which is negative, so a positive times a positive is a negative. And the same here, we have 0 discretionary monetary policy. That's the minus 2.5, and we have a 0 here. Now look over here, we have the same term here, but we also have our discretionary monetary policy. So now, if we go back to our equation, we remember that we have to add this, subtract this, add this, and we do that, we find that the output gap, the equilibrium output gap under our first alternative scenario is 1.1%. And our equilibrium output gap under our second scenario is 1.7%. Now, this ought to make sense to you because in this first scenario, yes, aggregate demand increased, but the central bank, it stayed on its Taylor rule, and we're going to find in a second that the central bank raised interest rates in alternative 1 when we compare this to the baseline. And we're going to find here that the central bank, because it did a discretionary loosening, it offset any effect of the Taylor rule, and it kept interest rates more or less constant in real terms relative to the baseline. So it turns out that we plugged in our equilibrium output gap into our equations for real interest rate, inflation, nominal interest rate, and what do we find? That here in alternative 1, where we had no monetary accommodation, our real interest rate rose from 2.8%, the natural interest rate in the baseline, to 3.6%, which is a pretty sizable height. So that's squeezing off some of that additional demand that we found was coming from our shock to aggregate demand here. So we were squeezing off some demand here. Now you'll see over here in alternative 2, because the central bank accommodated with a reduction in the nominal interest rate relative to what it would have done on the Taylor rule, it kept real interest rates constant at 2.8%. So you can see why the output gap is higher here than here, because real interest rates unchanged from the baseline in scenario 2, but higher than the baseline in scenario 1. Now we can also see the effects on inflation. It shouldn't surprise you that in both scenarios inflation rises, but inflation rises by more in scenario 2 than in scenario 1. Why? Well, we eased up on the monetary policy. Looser monetary policy, more demand, higher inflation. Now, you'll see here that in both cases, the central bank had to raise the nominal interest rate. Why? Because the inflation rate rose. So we see an increase in the nominal interest rate here from 5.2% in the baseline to 6.6%. And we see in alternative 2 that yes, the nominal interest rate was increased, but by much less, by about 50 basis points. So finally, how do we get a dollar figure for output? Remember that this is potential output. Okay, this is the baseline scenario, natural rate of interest, and potential output. We take the potential output times 1 plus the output gap to get our dollar figures for output in alternative 1 and alternative 2. So we had a 1.1% increase in output relative to the baseline. So that raised our output from 13,206 to 13,355, a little bit over 100 and let's say $50 billion. And then we over here we have 13 trillion 431 billion, and that's even higher. So this is 13,206,000,000, 13,355,000,000,000, and 13,431,000,000,000. That's a very easy calculation. So now the last slide I just want to show you, you want to know how we got these parameters. Well, these are the very same parameters. These are sort of the ingredients of our forecast. These are our assumptions. So you can see here that we have the marginal propensity to save, marginal propensity to import. We have our parameters from the Taylor rule. We have 1 over the short-run aggregate supply elasticity. We have summed up here the effects of the interest rate on consumption and investment. This is another parameter from our short-run Taylor rule. This is our response of the interest rate, monetary policy, to changes in the output gap. Okay, so this is our compound parameter here, our augmented multiplier. And you can see that natural rate of interest was assumed to be 2.8%. Our potential output was assumed to be 13,206,000,000,000, and our target rate of inflation was assumed to be 2.4%. The model can do this for you, but we recommend that you actually do some of the exercises so that this is not such a black box for you. These exercises are implemented in an Excel spreadsheet, and we think that you will have a good time doing those exercises.